In this video, we will talk about how we can control routing update traffic. Sometimes, guys, it may be necessary for some routes to be allowed to some destinations correctly and some to be rejected. So route filtering involves controlling which routes are advertised or accepted between routing protocols or within the same protocol. We can filter the routes with three methods. The first method is distribution list that filters routing updates by controlling which routes are accepted or advertised, and distribution lists applied to routing protocols like OSPF or EIGRP to include or exclude routes based on access lists or prefix lists. And there is some syntax to use it, which I will show you in our next slide. And we have the prefix list. It defines and filters IP prefixes for routing decisions, and it allows specification of which prefixes are permitted or denied in the routing updates. And we have the route maps. The route maps provide detailed control over routing updates by applying conditions and actions, and it uses some match conditions and set actions to filter or modify routes based on various criteria. Let's start with distribute list configuration and try to filter the loopback interface of router 1 from the routing table of router 3. How we can achieve it? So router 1 has a loopback address, and which is 1111/32, as you are seeing in here. So I need to go to router 3 to implement my distribute list. First of all, I need to define an access list. Then I need to apply same access list to my distribute list. Okay, so the configuration is like in router 3, I am defining an IP access list. IP access list standard, and I am giving a name which is R1L0. This access list is using to deny host 1111, okay, which is the loopback 0 interface of router 1. And this access list is permitting anything else. All right, that is some sort of I am, matching the IP address of loopback 0 interface of router 1 with using this access list. Then what I am doing, I am typing on router mode distribute list, and I am typing my access list name, which is R1L0 for this case. And then I am typing my direction, which is in for this case. So which means this route will advertise this 1111 interface to this direction, right? And this is an inbound direction for router 3. So whatever routes coming from this direction, it might be including this network as well as this subnet mask, will be hitting to router 3 in this direction, right? So what my distribute list will do, it will filter out this 1111, it will deny it, and it will permit anything else. Okay, so if I go ahead to router 3 and type show IP route 1111, I won't see anything in my routing table because I am simply denying it by using my distribute list. And I have the prefix list configuration. Okay, let's have a look. In router 3, I am defining some prefix list. Okay, there are two different routing domains in here. The first one is the OSPF domain, as you are seeing on the left, and the other one is the EIGRP domain, as you are seeing on the right. So I am defining some prefix list in here. IP prefix list The name of the prefix list is filter routes. Okay, and then I'm putting some description, and the description is outgoing route filter. Okay, then I am defining my prefix list statements. The first statement is saying IP prefix list filter routes sequence 5. That means that is the first statement for my prefix list. It will permit this IP and this prefix list. Okay, 10.10.11.0/24. Okay, that is one of the routes in here. Then I have another prefix list, IP prefix list filter routes. That is my second statement for same prefix list, sorry, with a sequence of 10, which permits 10.10.12.0/24. That is this subnet. Then that's it. There's nothing else, which means anything else apart from these two statements will be denied. Okay, that is the purpose of this IP prefix list. I am permitting this subnet with this subnet mask, this subnet with this subnet mask, and denying anything else. Okay, and I am going into my OSPF configuration, router OSPF 10, and I am typing some sort of redistribution command to redistribute routes from EIGRP domain to the OSPF, right? So redistribute EIGRP 100, metric 40 and subnets, that is used for redistribution from EIGRP to OSPF. And then I am implementing one prefix list. Distribute list prefix filter routes. Okay, that is my prefix list that I defined in here, out EIGRP 100. Okay, so what basically all those commands are doing when I am doing the route redistribution from EIGRP to the OSPF domain, I am permitting these first 11.0 and 12.0 networks, but I am denying the 13 and 14 networks to be redistributed from my EIGRP domain to my OSPF domain. And we have the route maps. Route map is a versatile feature used in network routing to control and manipulate routing updates based on specific criteria, guys. So it provides a way to apply complex policies to routes, such as filtering, modifying, or redistributing them. So that is a sample configuration of route map, and let's review it. So here I have one BGP configuration, right? And I am defining some of my neighbors. And here with this statement, I'm able to see there is a route map configuration, which is in direction. And the name of the route map is local pref. Okay. So, and I'm able to see I defined an access list 65, which is permit statement, and this is the statement 172.30.00 with a wildcard mask of 00255.255, which means it is matching first two octets 172 and the 30, right? And then I'm able to see I am defining my route map in here. So route map local pref, that is the name of my local pref, that is the name of my route map, sorry. Route map local pref permit 10, that is my first route map statement, okay. And this local pref route map is matching the IP address defined in access list 65, which equals to 172.30. Everything starts with 170.30 more correctly. Okay, and then I am setting a local preference value for this one as 400. Okay, let's review once again. So I have my route map, which is named as local pref, and permit 10 is the first statement of this route map. And this first statement is matching the IP address that I defined with my access list 65, which means it is focusing on everything starts with 172.30 and setting a BGP local preference value of 400 for these IP addresses. Okay, fair enough. And I see a second statement as well. Route map local pref permit 20. It is, and that means basically permit anything else, because otherwise everything will be denied if you just don't use this permit statement. So in the route map, make sure you are having another permit statement allowing everything else. Okay, so what I am doing is I'm going ahead and I am applying this for my particular BGP neighbor. Okay, and this is applicable only for this neighbor. Okay, so this route map will have no effect for this neighbor, will have no effect for this neighbor. Okay, so it will apply local preference 400 to this address range only for this neighbor during BGP neighborship. And I have redistribution and route map usage. That is another example. So for example, let's have a look to this configuration. In config mode, what I'm doing, I'm defining some access list. 23, 29, 37, and these are matching these particular IP addresses. Okay, so for example, the first one is matching everything starts with 10.1, etc. Okay, so same applies to the second one, is third one, they are matching some other specific subnets. Okay, this is how I am defining my access list. In the second step, I am defining my route map statements. So route map, this time the name is Redis RIP, and I'm having some other statements in here. So permit 10, that is my first route map statement, 20 is my second, and 30 is my third route map statement. So what I'm doing with first statement, I'm matching the IP addresses that I defined with access list 23 and 29. Okay, this one. And I am applying a metric value, which is 500 for this range. And I am setting the metric type to type 1, which means E1 routes. Okay, and then in my second statement, I am denying the IP address range that I defined with 37. Okay, this one will be denied when I'm doing the redistribution. And then I have my final statement for any other route which is not matching the first two statements. I will go ahead and set the metric as 5000 and metric type to 2, and which means they will be type E2. Okay, so then I am doing my final configuration. Route map router OSPF 10 and redistribute RIP okay, route map by using this Redis rip route map. Okay, so this is basically what this is doing. When I'm doing the redistribution from the RIP domain to my OSPF domain, I am applying this route map, and this route map will allow me to set some metric values, set some certain metric types as type 1 or type 2, or it will help me to deny some of the address ranges as well. So that is how it works. And lastly, we have the route tagging. Route tagging, that is a technique used in routing protocols to attach a tag or label to the route. So this tag is a value that can be used to influence routing decisions, filter routes, or implement routing policies. Okay, so here, we have two purposes. The first purpose is policy control. Tags will help in applying routing policies, such as controlling which routes are preferred or advertised. And the other purpose is route filtering, where the tags can be used to filter routes when redistributing or exchanging routing information. So here how it works in conjunction with the redistribution. For example, I have my route map again, which is EIGRP to OSPF. That is the name of my route map. And what I am doing with this route map, I am setting a tag. And tag is 50. Okay, so then I'm going to my OSPF configuration and I am redistributing EIGRP 100 subnets with route map EIGRP to OSPF. So this configuration basically means when I'm redistributing routes from EIGRP to my OSPF domain, tag them with a value of 50. Okay, on the other hand, let's see this configuration below. I have this time route map and it is OSPF to EIGRP deny 10 this time, match tag 50, okay, and exit. Okay, cool. So what this statement basically doing, everything with tag 50 will be denied by this route map that I'm applying for router 1. Okay, and then I have another route map statement, route map OSPF to EIGRP permit 20. Okay, which means it will allow everything else. So how I'm doing this configuration again, when I'm doing the redistribution from OSPF to EIGRP, the command was redistribute OSPF 10 metric, and I'm defining the delay, other values as well, followed with route map OSPF to EIGRP. So basically this route map will do something. It will match all of the routes coming with a tag of 50, and it will deny them to be redistributed, and it will allow anything else. Alright guys, we are coming to end of this session as well, and thank you so much for joining me.